Okay, so we were discussing about the RL circuits. So in the last lecture, we have seen that the current is having an equation in an RLC circuit. That means the inductor current IL of t is given by I0. That means the initial current into e power minus t over tau. Okay, and tau is the time constant, and it is nothing but L over R. This is the case in an RL circuit. Okay, that we have seen in the last class. Now we will see some problems based on this. So the first problem just means we will solve some problems which is to find out the time constant, just to find out the time constant. Okay, so determine tau for the circuit. Okay, I will not expand the whole sentence to save some time. Anyway, this is the circuit. You have a voltage source. Let's say this is the voltage source. Okay, V in is the voltage source, and you have 1 Henry inductance like this. Okay, so the what is the equation for the time constant that we have seen? Time constant is
L
L
by
over R. If there are more than one resistance and more than one inductance, then it is nothing but L equivalent by R equivalent. Okay. So first of all, we will short circuit the voltage source, and we will see from the inductance. How many inductance are there? There is only one inductance.
one.
Okay. So we will see, we will short circuit the voltage source. I short circuit the voltage source. This is the procedure. This is 2 ohm resistance, and this is 2 ohm resistance, and there is a connection here, and this was my inductor. Okay, and here was my inductor. Actually, this was my inductor. You can see here was my inductor. Okay, now I will see from this side. I have L equivalent is only one. L equivalent, that means it is 1 Henry. You know, this is 1 Henry, it is given. So 1 Henry. And as you see from the inductor side, if you see from the inductor side, what is R equivalent? Can you tell me?
1 ohm.
One.
Yeah, it is 2 ohm parallel. Yes. So it is 1 ohm. Okay. So the time constant tau is nothing but L equivalent by R equivalent, which is nothing but 1 Henry by 1 ohm. Actually, the unit is in seconds. Actually, it is not Henry per ohm. It's having a different meaning. That's why. So it is 1 second. That's the time constant actually. So the unit is in seconds. So it is not Henry per ohm. There is no physical meaning. So the unit is actually is in seconds, because Henry per ohm does not have any physical meaning. Okay, and also we have seen from the differential equation, L by R is a factor which is related to the time. That's why the unit is in seconds. Okay, so it is having the unit seconds. Okay, seconds. So that's very important. I hope it is clear to you, right?
Clear, sir.
Yes, sir.
So the next circuit, determine the time constant for the next circuit. Same thing. Okay, find tau. There is 2 ohm resistance. There is 2 ohm resistance here. Okay, now there is an inductor which is 1 Henry, same circuit, but there is a current source. So the current source is 1 ampere. So what you have to do to find the
Open
first
circuit.
of all,
the
you
current
have
source.
yes, open circuit the current source, and this is 2 ohm, 2 ohm. Okay, 2 ohm actually, and this from the inductor side you have to see. That's very important. From where you have to see? You have to see from this inductor side, because there is only one inductor here. So it's 1 Henry. So L equivalent is 1 Henry. And what is R equivalent here?
2 ohm.
Yes, it is just 2 ohm, because the other end is open circuit. So it is 2 ohm. So the time constant is 1 Henry divided by 2 ohm. Okay, so it is nothing but
Doctor,
half seconds. Okay,
Doctor,
yes,
why we don't consider the another 2 ohm resistance?
because if you see like this, what is the current through that? Can you tell me
Zero.
if you connect? If no, there is another meaning for that. If you have a current source like this, if you have a current source like this, 3 ampere, so same current source like this, but maybe 5 ohm. What will be the current actually? If you have some circuit here, some circuit here some circuit, whatever it be, what will be the current here?
It is 2 ampere.
Here 2 ampere. What about here?
It's also 2 ampere.
Yes. Is there any influence? Is it influencing? This is 3 ohm and other one is 5 ohm. Is there any problem? Because the current is same. Because you have a current source at the other end. You understood?
Yes.
So yes, and also that is the actual meaning. But when calculating, what you have to do is you have to open circuit. So when you open circuit, there is no connection here. You can see there is no connection at this end, no connection. Here there is no connection. You can see no connection. So you can avoid that resistance. That is not the part of the circuit. You understood? That is not going to influence the current. You understood?
Yes, Doctor.
Yeah, that's why. So that's the reason. Okay. Now, inshallah, we'll see the next problem. Here, no connection. Okay, I will write. So next problem. You have to find the time constant. You have a 10-volt battery like this, 2 ohm, and this is again an inductor, 1 Henry, and I think it's 9 ohm. Yeah, then 2 Henry, again 2 Henry. Okay. Now what you have to do, you have to short circuit the current source. Is it sorry, voltage source? You have to short circuit the voltage source, and you have 2 ohm here, again 2 ohm. Now I am going to play a trick here because I am going to. This is 2 Henry. It's an inductor. Okay, I have made a mistake here in the drawing. It's inductor actually. That's why 2 Henry. Coil here, coil here. Okay. Now you see here. What I'm going to do is I'm going to change the 9 ohm here and 1 Henry here. Is there any problem? Is there
No.
any issue?
No problem, sir.
No,
Yes.
Doctor.
Now I can see all my coils on one side. This is 2 Henry. Again 2 Henry. So now it's very simple. So what is the total L equivalent for this circuit? L equivalent.
200
You
and
have
200
200,
parallel.
200
2 Henry.
Serious
200
parallel.
in parallel.
That 2 Henry and 2 Henry is in parallel. It will be 1 Henry. 1 Henry and 1 Henry become series. Then it will become
1 Henry.
200.
2.
Yeah.
yes. So 1 Henry. So I will write the steps. After a few days, you may not get it. That's a problem. 2 parallel 2 plus 1. That is equal to 2 Henry. Now what is R equivalent? You can see 2 and 2 is parallel. So it's 1 ohm. 1 and 9. It yes. So 2 parallel 2 plus 9. It become 10 ohm. So you can calculate the time constant here. Again, the time constant L equivalent is 2 Henry divided by 10. Okay. So ohm, that's 1 by
1
5
by second.
seconds. Okay. That's so this okay. So what you will do if you cannot separate this like this, if you have a combination, suppose you have a circuit with the inductor here and something like this, what you will do, sorry, in this case, what you will do here? If you have a circuit like this,
Will calculate the impedance of them.
no,
I mean the reactances and things.
no, not reactance. Actually, reactance has nothing to do with this. Time constant is the factor. Actually, time constant is L equivalent by R equivalent. So in this case, there is no one inductor. Actually, there are more than one inductor, even though you cannot combine them. That means you cannot combine them in this case. In the above case, actually, you can't combine. Is it any way?
Doctor,
Yes.
I think we can, Doctor.
We cannot combine. How you can combine L equivalent?
If you
You don't want
if you short circuit the source,
Hmm.
then find the total impedance. The imaginary
Impedance
number,
is
it will be the inductor, and the real number will be the resistance, and you just divide. You got me?
no. It's no. It's not like that. Okay, that is not possible because whenever you are talking about something known as the impedance, from where that the concept is coming, that concept is coming from the phasor. You know phasor representation, right?
Yes, sir.
So when you are talking about the is a DC circuit, actually we are talking about DC transients. Of course, some frequencies will come because of the exponential behavior, but it's not in the same way as we usually handle the AC signals. So for an AC circuits, we usually find the impedance, but here for finding the time constant, that will not work. Both are different logic. That is the problem. So in this kind of circuit, we have not only one time constant, we have multiple time constant in this kind of circuits. You can see I cannot combine this end, right, with this end. Is it possible?
Yes, I understand, Doctor. Because
Yes.
DC
So
circuit, the
yeah,
inductor will not be impedance, will be short. Will be short
yes,
circuit
here
of
the
some
problem, you can imagine like that. There are two impedance. Just assume like this. You have two different inductance. You cannot combine them. For example, you have only two inductance. I will take a simple case. This three inductance are there. If you have two inductance and you cannot combine them, then in such a case, the meaning is this circuit is having more than one time constant. It is having more than one time constant. You understood? Let's say this is L1, this is R1, this is L2 and R2. So there are two time constant in this circuits. You understood? Because
Yes, sir.
there are two different inductors. Inductors will demagnetize. You know, inductor will release the energy when you demagnetize, right? That means when you remove the sources, it will decay. Exponential decay will be there, right? That we have already seen. So this will decay in two different ways. One will be having one time constant like this. One will decay like this. So according to the value, sometimes both will be same value. According to the, so we can combine these two. We have another combination. So we have two time constant in this circuit. Okay. So in this kind of, if you cannot combine, the meaning in that kind of circuit, you have multiple time constant. You understood? Multiple time constant. There are some
Yes.
circuit, if you cannot combine, there are multiple time constant. That means you have different components. That means different inductors will demagnetize and release the energy at different times. So according to the one time constant, suppose there are two time constant in the system. According to the first time constant, the current will decay, and according to the second time constant, another current will decay, because there are two branches and two branch currents will decay at different, according to different time constant. Understood? So there are multiple time constants. That is the,
Doctor, excuse me.
so this is a special, yes.
I have question.
Yes, yes.
We
Yes, yes.
cannot find the impedance in DC circuit because the
we can find the
frequency is
impedance.
0.
We can find the, you see here, what is the meaning of n? In a DC circuit, suppose if I am talking about, what is the inductor in a DC, what is the impedance of the inductor? Can you tell me? It's
J
J
omega L.
omega. What is the
omega L.
frequency? What is omega in?
2 by F.
Omega, omega DC. What is omega for DC signal? For DC.
Zero.
I'm
Zero,
talking about
zero,
DC.
zero.
Zero.
Because the frequency is 0.
Then what is the reactance for this?
Will
Zero.
be 0.
0 ohm means it's a short circuit. That means inductor is a short circuit. It is showing the steady state condition. It is not showing the transient condition. Am I correct?
Yes, 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 yes.
Now for
Yes,
the
sir.
capacitor. Now the capacitor 1 by j omega c. Omega equal to 0 means infinity.
Infinity.
Infinity means capacitor is open circuit. Open circuit means
Steady state.
open circuit. It's a steady state actually. So we cannot manage that theory here. Actually, we cannot use that theory, and it cannot be used to manage the time constants and all. We cannot find, okay, the transient behavior by using
Yes,
that. Okay,
yes.
I hope it is clear to
Yes,
you.
I
Right.
got it, doctor.
So,
I got it.
yeah. Now, so there are some theories which will not work, and actually you are making this is absolute. You have to make a theory, understood? And if somebody is coming with more profound theory, which is universal, which is working at all condition, then that will dominate over your theory. You understood? So that is the situation. So don't think that science is an absolute solution. It is nothing. It's zero actually. So we are making theories to make it suitable for some particular condition, and we are using to solve such condition. And if we add some more dimension, if the physical phenomena is having another dimension which cannot be included or which cannot be explained, I think you know that excuse me, I think you can hear me, right?
Yes, doctor, but sometimes
Cut
your
it.
connection
Cut it,
disturbs.
doctor. Not sir.
Yeah, actually I received a call, that's why okay, now it's okay, right? I think so.
Yes, yes.
Connecting through my phone, if somebody calls to my phone, then it will become a big issue. That's the problem. So what I'm saying is that do you know about the classical mechanics, Newton's mechanics? You might have heard about
Yes,
Newton's
yes, we
three
have
laws of
studied it,
motion.
doctor. We
Yes,
have studied subject.
Yeah,
about static
if
and
you
dynamic.
cannot use that theory, if you cannot use that theory to study about the subatomic particles. Subatomic particles are protons, neutrons, electrons, and their movement, their motion. Even though it is a mechanics, classical mechanics is a mechanics. Mechanics means it is something related to the motion. You cannot use that theory to explain the phenomenon which are related to atomic particles in atom level. You understood? So at that time, you have to use a different theory, which is known as quantum mechanics. Have you heard about quantum mechanics?
Yes.
Yes, I heard about it.
Yeah.
It is
So then you have to
similar
use the, yeah, you have to deal in another thing actually. It is completely different. And classical mechanics, you can see that it is a special case of quantum mechanics. And even quantum mechanics is not absolute thing actually. Some theory will come inshallah later. So that is about the science. So science don't believe in science. Okay. So you can use some theory, you can develop some theory, use it for your applications. That's it. More than that, it is nothing. Okay. Then we will
Yes,
see another case. Okay. Source free. We were talking about source free RL circuit. Now we will talk about source-free RC circuit. Okay, we will talk about RC circuit. So source-free RC circuit means, first of all, you will be having a resistance and you will be having a capacitor. Okay, and this is the ground point. And first of all, you have to charge the capacitor by using there is a switch, there is a some R1 and some voltage source V1. You are going to charge the capacitor, and at time t equal to 0, you open the switch, then your circuit to become something like this. As I told, it to become simply, you have a capacitor, you have a resistance, this is a capacitor, that's right, and we will be having some initial voltage across this. Let's say this is V0, and this voltage will become, how much is the voltage across the capacitor? It will be V0, right?
V0.
V0.
V0, yes. Now I will write the Kirchhoff current law here. I will take this
Doctor, why
node,
we
you
use
can
the
consider.
R1?
Yeah, because I need to
Only use the
limit.
voltage source?
I can use the voltage source only because otherwise there is I need a protection for the voltage source. If I do not limit my current, you connect a capacitor directly to the battery, then there is a problem. What will you can sometimes see some spark. Understood? You can see some spark because of the high
resistance
current.
0, the current will be infinity.
Yes, very high, and the capacitor will charge very fastly. Time constant will be approximately 0, you can say. So because of that, and very high current will flow through the battery, sometimes your battery get heated up. So for the protection, we will always use a resistance in series with the battery. Okay, I hope it is clear to you. Now we have the capacitor. Okay, now I will talk about, I will consider this, you can consider this node. So there is a current here, this is the current through the capacitor. This current is leaving from here, which is the current which is IR. So what is the KCL? KCL will say, give you IR plus
IC.
IC equal to
equal to
0.
0.
So let us assume that the node is having a voltage V. You can say the initial voltage across the capacitor is V0, that I have already told you, that we will talk later anyway. Let's say in general the voltage is V of t, you can say in general. Okay, so V of t. So what will be the current IR? IR will be V of t over R, right? Plus what will be the current through the capacitor? Current through the capacitor will be C into dV of t over dt. So you can see this total equal to 0. So you can see here, I will write the equation in this way, dV by dt plus, I will divide the whole equation with C, you can say. Then I can write like this. It is 1 over RC into V of t is equal to 0. Is it okay? Same.
Yes.
Okay, because the right side is 0, I can do anything. Right side is 0. So that's why. Now dV of t, this is V of t. Okay, V of t. Now I told you for differential operator, I have already used d plus 1 over RC into V of t. You can like this. This is an d is a differential operator. This is equal to 0. What is the solution of this? V of t we have already seen. This is a different equation, same kind of thing we have already seen. What is alpha here? Alpha is
T plus 1 by RC.
alpha is equal to root of this. You can see here, d plus 1 by RC equal to 0. So d equal to minus 1 by RC. So alpha, we will say it is 1 minus 1 by RC. Is it okay? We have already seen the same type of equation in inductor, but the equation was for current. Here the equation is for voltage. That is the only difference. I told you inductor and capacitor, inductor and capacitors are dual. One is for voltage and another is for current. That is the only difference. Their behavior is almost same. Your mathematical structure is almost same, but one for voltage, another for current. Capacitor is for voltage and inductor is for current. And the current means magnetic energy or static energy. And voltage means electrostatic potential or
electric energy.
electric field. Okay.
Electric
The other one is magnetic field, electric field. Magnetic field is always related to the current. Electric field is always related to the voltage. That is the only difference. They are dual, like male and female.
Yes.
Like male and female. By combining this male and female, we will be having different kind of phenomenon. That is the beauty of this thing. So the male and female is everywhere. You have seen everything has been, Allah has created everything as Zawjain, you know that thing. So V of t is k into e power minus t over RC. Okay, this is the solution. So the solution, I will write it. V of t is equal to some constant k into e power minus t by RC. Now at t equal to 0, now V of 0 is equal to k into e power minus 0. So V of 0 is nothing but k, right?
Yes.
That means V of 0, I will give another name. I have already told you my capacitor is charged to V0. Here I told you my capacitor was charged to V0, right? So my V of 0 is V0. So my general solution is V of t is equal to V0 into e power minus t by RC. Again, this equation is having the same form. It is having the same form, V0 into e power minus t over tau. What is tau here? Tau is RC, right? Yes, tau is RC. So in a circuit which is having RC circuit, the time constant is just RC. So if you plot this, you will get the curve like this. This is your time, and this is your V0, and the curve will move like this, as I told. Yeah, decay, and it's going to 0. And at this point, you will say this is t equal to 5 times time constant. I told you it is less than 1% of V0. It is less than 1% of V0. The value is very, very small. If the V0 is 100, if V0 is 100 volt, at this point, V0 will decay and V of t may be less than 1. 0.06, I think, yeah, 0.6%, 0.6 volt. You understood? It's very small. And I know,
Yes.
I told you always about time t equal to tau, what will be the value? I have already told you. Okay, at time t equal to tau, the value is 0.368 V0. Okay.
Doctor, I have a question.
Yes.
Tau isn't the value that the time that the beginning value is reached 63.8, I think, or 63.2.
That you have
Yeah,
already. I think you got this idea by memorizing that fact. I think so, right?
Yes, because we
Yes.
took it like this, I think.
Yeah, there are two different things. We are talking about a circuit without any source. Your capacitor is discharging. You understood?
Yes.
Your capacitor is discharging means you have the maximum, means maximum is 100%, right? Maximum 100%. What is this? 36.8%. Yes. So if you are discharging, how much change is there? Can you tell me? 63.2.
63.2.
Yes. What is this gap? That's the main thing. So this gap is 63.2 in discharging case. In charging case, this is, there is no charging here actually. I will just show you. In charging case, this is the maximum, V max. Then this is the value, 63.2% of V max. then this is time t equal to time constant. That we will see inshallah later. Okay, so the time constant is
Oh, so one is for
everything.
charging,
Yeah,
and other one is discharging.
discharging. So but anyway, both are same. How much change is there? This is starting from 0. How much change is there? How much change?
26.
63. No, not 36. Change 63.2.
Yeah.
Now, because starting point is this is start, right? Starting from here, from 0.
Yes.
Now, in the previous case, where does this start? It's starting from 100 and it reaches 36.8. How much is the change? 63 point?
Same.
2.
Yes.
Yes. That's the meaning. Okay, I hope it is clear to you, right? So this is this area, this region is the transient period. Okay, it is the transient period, and after that, after 5 times time constant, it's steady state, we will say. This is theoretical. Okay, steady state. That means the change is very, very small in steady state. That's why. Okay. Okay, this just to make a note of this. Okay, I am not going to remove it anyway. Now we will see some problem to find the time constant. Okay, find the tau. So you have a voltage source, 1 volt, and you have a 2 ohm resistance. The same problem, same type of problem, 1 ohm resistance capacitor. So how to find the time constant? Again, R equivalent.
RC.
voltage source.
Yes, R equivalent into C equivalent. So you know how to short circuit all these things and find it. So this short circuit, so 2 ohm, 2 ohm, that's it. This is 1 ohm. Then this is 1 farad. Okay, 1 farad. So you will start from here actually. So it is 1 farad. Okay, 1 farad. This is C equivalent is 1 farad. And what is R equivalent? R equivalent is you have, yes, 2 parallel 2 plus 1, that's equal to 2 ohm. So the time constant is 1 into 2, it becomes 2 seconds. You understood? So in what is the notice? In this circuit, what is 5 times time constant? 5 times time constant. 5 into
10 seconds.
10 seconds.
yes. After 10 seconds, your capacitor will discharge almost. Understood? And it will reach a value nearly 0.
Yes, doctor.
Yes, after 10 seconds. That is the meaning. You understood? So after 10 seconds, yes, you remove the source from the circuit. After 10 seconds, your capacitor will discharge. After 10 seconds, your capacitor will discharge. Anyway, I'm not going to write it. Inshallah, we'll see detail in some problems, inshallah. So the same kind of problem with a current source. I told you this. It's 1 ampere current source. This is 2 ohm, 1 ohm, and there is a capacitor 1 farad. Okay, so in this case, what will be R equivalent without anything? You have to remove the open circuit the current source. Then R equivalent will be 1 ohm, 2 ohm, 3 ohm, right? And C equivalent you will get 1 farad. So the time constant is
3 seconds.
3 seconds. Okay, that's it. So we have finished that kind of problems. Now we will see some other kind of problems which are related to the source free RLC circuits. So we will talk about some problems on source free RLC circuit. Source free, not RLC, sorry, RLC we will deal later. That is a very interesting phenomenon. RL circuits. Okay, so the first problem, you have a current source. You have a current source like this. It's 2 ampere current source, and there is some resistance which is connected to the current source, which is 30 ohm, like this. Okay, and there is a switch here, and at t equal to 0, you are opening the switch at t equal to 0. That is the meaning of this kind of notation. The switch was closed for a long time, and at t equal to 0, you are opening the switch. I hope it is clear, right? Now we have this inductor. We have the inductor. Okay, we have the inductor, which is 4 Henry, and there is a resistance which is in parallel to the inductor, which is 20 ohm. Okay, now can you tell me what is the situation in this circuit? We will talk about. Excuse me, can you hear?
Yes, yes.
Yes, doctor.
Yes,
Yes.
Dr. Mohammed.
First, we take the initial current in the inductor.
Yeah, first of all, we will find the steady state value of the current through the inductor, because we are talking about t equal to 0. That means the inductor, the switch was closed, the switch was opening at t equal to 0. At this t equal to 0, the switch is opening. Before t equal to 0 means t equal to 0 minus, and another is t equal to 0 plus. These are all the different conditions. We have to be careful. So this is t equal to 0. So what was the situation when t equal to 0 minus? So inductor a
It was
short
closed.
circuit, right? Right? Inductor become a short circuit. Do you agree with me in this regard?
Yes, sir.
Inductor was a
Gonna be
Yes.
so 30 ohm you have here. This is a short circuit. Inductor is a short circuit, and you have some 20 ohm here. So the 2 ampere current will flow through the resistance or inductor.
through inductor, doctor, because there's short
Yes.
circuit.
Because it's short.
Short circuit. So no current will be through the resistances. The current through the resistances will be 0. So the current through the inductor, this current we will say, yes, it's 2 ampere. So since the current is flowing through the inductor, I will talk about the inductor only now. So current is flowing through the inductor like this, and it was 2 ampere. What is the polarity of the voltage? Plus and minus. Okay, is it okay? So this is the
Yes, sir.
situation. This is the situation at t equal to 0 minus. This is the situation. I hope it is clear to you. Situation before t equal to 0. That means it at t equal
Yes,
to 0
doctor.
minus. So before opening the switch, this was the situation. Now, after opening the switch, so we will mark the polarity of the voltage VL of 0 minus like this. Okay, VL of 0 minus like this. Now, after the switch is after that switch is what we are doing to the switch is opening. Okay, so after the switch is opened, you see here, I will draw the circuit again. You have something, this is t equal to 0, so this is your inductor and this is your resistance. When you open the switch, what will happen at t equal to 0 after opening the switch?
The polarity of the inductor will be opposite.
No. Okay, the polarity we will talk about later. We will prove it mathematically. Okay, previously it was, the current was like this.
We will only have the inductor and
The current
resistor.
is 2 ampere and the voltage was like this. Do you agree with me? This is VL of 0 minus.
Yes,
It
sir.
was like this. The voltage polarity is like this previously. Now, when you open the switch, you have only one part of the circuit. Other part is lost because there is no connection to the other part. Okay, 2 ampere current is flowing like this. Is it okay?
Yes.
So
This is the situation at t equal to 0 plus. Okay, polarity of the voltage we will talk about later. Okay, talk about it later. Okay, we will talk about the current first. Okay, so at t equal to 0 plus, so IL, there is no impulse voltage or something like that. So IL of 0 minus 0 plus will be equal to IL of 0 minus. Do you agree with me? This current will be same.
Yes.
yes, sir.
And this
Yes.
current, we will call in general as IL of 0 it is nothing but 2 ampere. We have already find it. Now, what is the equation? What is the equation? Equation for the
I
current.
equal I naught
We still have to find the
Yes.
tau.
Yes,
or
the
T by
current will
tau.
be flowing. The current will be flowing like this. Now, full energy at t equal to 0 plus, there was full energy, magnetic energy across the inductor. There was full energy across the inductor. Now, inductor is acting like a source. Inductor is acting as source. We will see what will happen to the polarity of the voltage. You have marked the polarity of the voltage like this previously. We will see what will happen to this polarity. Okay, inshallah, we will see later. Now,
Doctor, what's the question?
yes.
What's the question? What's asked for?
No, not ask any question. I am saying we will see about the polarity of the voltage later, inshallah. Okay, that's what. So IL of t, the current through the inductor, is nothing but I naught into e power minus t over tau. And what is tau? Tau is L by R,
L
right?
by R.
What is L? L, I forgot to write it, I think so. L in the previous page, actually. L is 4 and R is 20. L is 4 Henry and R is 20 ohm. So L over R is
1 by
4.
5 seconds.
Yes, it's 1 by 5 seconds. So what is the equation IL of t for the current? IL of t will be 2 ampere into, okay, 2 into, I will just write 2 into e power minus t by tau. 1 by 5. It become 5 into,
-5.
yes. So minus 5. Okay, this is the equation for the current. Now you can see this equation, it's something like this. Like this. So you have initially 2 ampere current. At time t equal to what we say at t equal to by 5 seconds, that is t equal to tau, you will have how much percentage we have told? 30 something. How much?
36.2.
Yes,
36.2.
36.2. That means you have to multiply with 2 into 0.368. That will be the value of the current at this. Okay, because maximum was 2 ampere. Now this is the point t equal to 5 times time constant. What is 5 times time constant in this case? 5 times time
It
constant.
is,
One.
it is
1
1 second.
Yes, then the value is very close to 0. It's less than 1% of the maximum. 1% of the maximum is it's 2 into 1 over 100, 0.02. So the value will be less than 0.02 ampere. It's very small number. Okay, this is the situation. Now what we will see the equation. We'll write the equation in next page. IL of t is equal to 2 into e power minus 5 into t. We will see what will happen to the inductor voltage. The voltage across the inductor at time t, and all these t's are greater than 0 or greater than or equal to 0, we can say. So what is inductor voltage? Inductor voltage is L into dIL of t by dt. You know this formula. So what is L? L is 4 Henry. I think it's 4 Henry, right? Yes, it's 4 Henry. So 4 Henry into
-40
yeah
-5t.
into dIL. It's 2 is a constant. So into minus 5 into e power minus 5t. Okay, is it okay? So you will get it as
Yes.
4 into 2. Yeah, it's minus 40 into e power minus 5t. So see here, the voltage across the inductor I have marked like this
Minus.
previously, but the actual voltage is minus of that. That means you can see this will give you here plus and this will give you minus, and the inductor will carry a current IL of t. Is it okay? This is the actual polarity.
Yes, sir, yes.
Actual polarity. That means it means that your inductor is removing its energy and it is giving its energy to the resistance. Now the inductor is acting like a source. So the conclusion is that your inductor can change the polarity instantaneously. It can change the polarity immediately. If it does not change the polarity, all the Kirchhoff will not be satisfied, you can say. If it does not change the polarity, what will happen? If you write the mesh equation, if you write the mesh equation in this,
there is the source.
yeah, then it will not be satisfied. And you know that all the networks will satisfy the Kirchhoff law, or it has to obey the Faraday's law also. This is also related to the Faraday's law. So it has to obey the Faraday's law. So that is the law, actually, that is the law of the networks. So it will satisfy this, but it can satisfy only by changing the polarity. So inductor can change its voltage instantaneously. I think it's clear to you, right? Instantaneous.
Yes, sir. Yes, clear.
But it cannot change the current instantaneously unless you give an impulse voltage that we have already seen in the last week. If we give an impulse voltage, it will change the current. Otherwise, it will not change. You understood? Yeah. So
Yes.
that's about the this problem. So please understand the concept that I am explaining through this problem very clearly. Okay. So what is happening to the voltage across the inductor? Inductor voltage is actually decaying. If you plot this, you will get something like this. It is starting from -40 inductor voltage across the inductor. It will go like this, and it's go 0. You understood? Just opposite. Understood?
Sure.
Yes.
Yes. And you can also see at time t equal to tau and at time t equal to 5 times tau. When it reaches 5 times tau, your value will be nearly 0, steady state. Okay, very close to 0, 0.0, very close to 0. So that is very important. Inductor can change the voltage instantaneously. That's what we have seen through this problem. Okay, now we will see other problem. This is 40 ohm resistance. There is a switch and you are opening the switch at time t equal to 0. The switch was closed for a long period with a 24 volt power supply, and you are opening the switch at t equal to 0. And you have a
Doctor,
yes.
long period means infinity.
Infinity means you don't need to switch on it for a you don't need to switch on the circuit for 100 years. No need for that. You just need to switch on the circuit at least 5 times time constant, at least.
Yes.
If
Because
you are
previously
switching on,
you said if t was 0 plus, the inductor
Yeah.
will be open, short. But infinity, it will be short.
yeah, but I am saying about this thing. Okay, in the previous case, inductor was short circuit. I think you are confused with this thing. Okay, this was right. If you are opening the switch at time t equal to 0 like this with a power supply, this is what you are saying. You can manage the current here, and at time t equal to 0, you can open the switch and you will be having a circuit with the same current like this. So inshallah, I will explain to you through this problem, inshallah, then it will be clear. That's better. Don't mix up the things. Okay. So this is 5 Henry. Now the switch was closed for a long period. It means that your circuit was in steady state for a long period. That's the meaning. I hope that is clear to you, right? Is it okay?
Yes, doctor.
Yes, sir.
Yes, the circuit was in steady state for a long period. Okay, after steady state, you are removing the switch at time t equal to 0. The moment you are removing the switch, from that point onwards, you will start counting. That's why you are assuming it as t equal to 0. Otherwise, you can assume any number. The moment you are opening the switch, at that point onwards, you will start counting. You will turn on your clock or timer. You understood? That's the meaning of that time t equal to 0. There is no other meaning for that time t equal to 0. Actually, there is no time minus infinity, we can say. You understood? Your current time, that means the moment at which you are opening the switch. That is the point where you are counting or starting your timer. That's why it's the time t equal to 0. Now, what will be the situation in the steady state? The switch was closed.
The inductor will be short circuit, and you will find the current through the resistance 10 ohm.
This is for the inductor was short circuit like this. Not inductor, that's time. The switch like this, and the inductor was short circuit. Short circuit. This is 5 Henry. So what will be the current through this?
10 ohm.
It
This
will
is
be
20.
2.4.
2.4.
Yes. So the current through the current through the inductor IL of 0 minus just before time t equal to 0. This is time t equal to 0, and this is 0 minus, and this after 0, that means it's 0 plus. Just after 0 is 0 plus. So the current will be 24 by 10. It will become 2.4 ampere. That's the current. Okay. Now you know that there is no impulse voltage or nothing acute. So IL of 0 plus will be equal to IL of 0 minus. Okay, because inductor cannot change the current instantaneously. Yes, 2.4 ampere. Now at t equal to 0, what will happen? We will see. At t equal to 0, you are opening the switch. You are opening the switch means you have 40 ohm. Yes, there is no connection here. Open circuit at this end. This is 10 ohm, and this is the case for time t greater than 0. Okay. At time t equal to 0, what will be the situation? Can you tell me? At t equal to 0, the inductor will be short circuit or open circuit?
Open.
Yes. So if inductor is open circuit, if inductor is open circuit, how you will show the current? Initial current, IL of 0. You can say this is IL of 0. How you will show? It is not short circuit. How the inductor will be short circuit? Inductor will be open circuit actually. The moment you are changing the voltage, inductor become open circuit, you can say. So how you will represent? Do you remember this notation I have shown you before?
Yes.
Yeah, that is the notation.
Yes.
To represent that thing. Okay, anyway, I am not using it. If you want to represent, you can represent like that also. Okay, so you can assume there is a current which is I naught. And what is I naught here? It is 2.4 ampere. Okay, now what is R equivalent? Please tell me R equivalent. It is 50 ohm, right? And L equivalent, you can say it is 5 Henry. So the time constant is L over R, L equivalent by R equivalent, which is 5 by 50. How much? 1 by 10 seconds, I think so, right? Am I correct?
Yes.
Yes. Now we will write the equation. Inductor current IL of t is nothing but 2.4 is the maximum, e power minus t over tau. Tau is 1 over 10. So you will get it as 2.4 into e power minus 10t. Is it okay? IL of t.
Yes.
So you will get here like
Yes,
this.
sir.
Yeah. Now, what is 10 times, sorry, what is 5 times time constant? What is tau? Tau is 1 by 10.
That is
So 5,
1 over
1 by 2
2.
seconds.
yeah, 1 by 2 seconds, right? It's 1 by 2 seconds. So after this is tau is equal to 5 times time constant. So after 1 by 2 seconds, what will be the what will be the current? Current will be almost
0.06.
almost 0.
Almost zero. Very close. Yes, very close to 0.
0.0024.
Yeah, just yeah, less than 1% actually. It is less than 1. It is just 0.06, means it is less than 1% actually. It is 0.006, or you can say 0. Actually, exactly you can say 0.6%, or for remembering, less than 1%. That means almost 0, you can say. So that is the problem. What will be the voltage across the inductor? The voltage across the inductor will be 2.4 L into, what is the equation? L into DIL of d
L2
by
di
dt.
by dt.
Yes, L is 5 Henry. 5 into DIL means 2.4 into minus 10 into e power minus 10t. I think it's correct, right? So
Yes.
you will get it as minus 96 volt, minus 96 into e power minus 10t. Okay, this so this is the voltage across the inductor. You can see again at VL of 0 plus will be the voltage the moment just after closing the switch. It will be minus 96 volt. Okay, so you can see again the inductor is changing the polarity. Inductor changes its polarity, and you know, when the inductor changes the polarity, if the inductor changes the polarity, yes,
Why inductor change its polarity?
because there is no other source. Inductor, that's what I have told in the previous problem. If the inductor does not change the polarity, we will see what will happen. Okay, we will see with this problem itself, not other problem. So let me consider here. This is 10 ohm resistance. This is 40 ohm resistance. I will conclude with 50 ohm resistance. Is it okay? Series. Okay.
Okay. Yes.
Now I have an inductor. This was my current actually. This is the case before. This is the case at t equal to 0 minus. The current was 2.4 ampere. Now, if it was like this, plus and minus, then what will be the voltage here? If you write the Kirchhoff law, this is the current. This is the current. I am talking about the case t equal to 0 minus. So this is plus, this is minus. Okay.
Okay.
Is it okay? So what will happen if the inductor does not change the polarity at t equal to 0 plus? Now you can see these two branches are parallel. Parallel voltages should be same.
And it
Yes, if the parallel, you see, if you have plus minus 5 volt, in the other part also it will be plus minus 5 volt, right? Like this. But here you see inductor current is flowing like this. If the inductor current flow like this, okay, and the polarity is suppose like this, at t equal to 0 minus, the polarity was like this, t equal to 0 minus this polarity. And if the inductor current flows like this, then what will happen to the polarity of the resistance here? It will become plus and minus. Now when that, this is the case t equal to 0 minus, when the time reaches t equal to 0 plus, what will happen? When t equal to 0 plus, if this condition is prevailing, then there is a problem. You see here, one side is minus, another side is plus. This is plus and this is minus, and these are parallel. Parallel voltages should be same. Understood? If it is not same, it will not satisfy Kirchhoff law. So, or Faraday's law. In order to satisfy the Faraday's law, we can say the other way. It's a converse of the theorem. That is, if in order to satisfy the Faraday's law, what will happen? Inductor should change the polarity. There is no other option for the inductor. So inductor will change the polarity. This become plus and the other end become minus. That means
But
your
they are
inductor is
not
now
always parallel, definitely.
not always.
Not always in parallel, like the previous problems. They are in series.
You see here, this is parallel actually. You see in the previous circuit also. This also, you can see there is a ground actually. There is a ground which is told here. I didn't show. There was no issue when the switch was closed. There will be some current here. There will be some current here. There is no problem. You see, this is plus, this is minus. This become plus, this become minus. Plus, minus. There was no issue. But the moment you open the switch, then everything become big problem. You understood?
Yeah.
The moment you open the switch, what will happen? What about this current? The current, please see my pen. The current that I am showing here. What will happen to this current? This current should change the direction, right?
Yes. Yes.
Because it is a resistance. Resistor has no problem. Resistor current can change the direction at the same instant. You understood? Because this guy, this current will not change the direction. The second current, this is the second current and this is the first current. First current will change the direction because he is very polite. Second current, inductor, yeah, he will not agree. I cannot change the direction. So inductor will not agree. So this current will be flowing in the same direction. So what will happen to the first current? There is no first current or second current now. Now there is only one current, right? Because the center part of the circuit is now open circuit, right?
Yes.
So what will happen? The polarity of the voltage across the resistance will now change. It become plus and minus. If it become plus and minus, then what will happen? Inductor voltage also should change in the same way, right? Inductor voltage should change in the same way. If inductor does not change voltage in the same way, the circuit will not obey the Kirchhoff law and everything will become problem. So that kind of behavior will not be expected from the circuit. So that's why the inductor is changing the polarity. I hope it is clear to you, right?
Clear.
Yes.
So just think, I don't know, I thought of completing some more problems. Okay, inshallah we will see some more problems. Now there is another problem. I think I will give it as an homework. Okay, this is question number 3. You can check it. This is 5 ampere and this is 8 ohms. This is position 1. There is a position 2 also. This is the switch. Your switch was in position 1 and it is going to position 2 at time t equal to 0. So previously it was in position 1 and the switch is now going to position 2 at time t equal to 0. And at position 2 there is something which is there is a resistance 12 ohm and here there is a 2 ohm resistance and this is a 3 Henry. Okay, you have to find the IL of t, the equation for IL of t, the voltage VL of t. Okay, that's it. And the time constant. Okay, of course there will be time constant for the circuit. Please try to do this problem. It's a very simple problem. First of all, you have to connect the switch to position 1. After that, you have to find what is the steady state current through the inductor. Then that will be IL of 0 minus. After that, you will find IL of 0 plus. It will be the same value. Then move the switch to position 2 and calculate the response. Okay, I hope it is clear to you, right?
Yes, doctor.
Now there is another
Yes,
problem.
clear, doctor.
Okay, so one problem. This is a typical problem. This is not so. It is not same as that of previous kind of problems anyway. There is a dependent source. This is IL by 4 ampere. And IL means, you know, it is the notation for the, right? So this is a dependent source. IL means it is the current through the inductor actually. So there is a current through inductor. This is the current IL through the inductor. Now you have to find out what is the response of this. You have to assume first of all it is given IL of 0 is given, it is 10 ampere. Okay, find the time constant of the circuit. Okay, that is the question. What is the time constant? And you can have also what is the voltage VL of t. These are all the questions. Can you tell me how to solve this? There is a dependent source, that is a problem. So in this kind of problems, we cannot solve in that much simple way. We have to, first of all, we have to use a trick here. We will use the source transformation. So because it is very convenient to work with the voltage source. So we are going to apply the voltage, the source transformation here. So this I will change into a voltage source. What will be the voltage source?
5IL.
Yeah, it will be 5IL because just multiply with 20 ohm resistance. Now 20 ohm will come in series. So what will be the total resistance? It will be 20 plus 10, 30. Okay, that's it. Yes. Now you have this circuit. Okay. And there is no shortcut for this. We have to write the loop equation. So this is minus 5IL, right? Minus 5IL. This is the current. This is plus, minus. So plus IL into 30. Okay. Plus IL into 30. Then what is the voltage across the inductor? This is plus, this is minus. Plus
It is L multiplied with di by
yes,
dt.
L is 5 into DIL by dt, and this should be equal to 0. I hope it is clear to you, right? So I can simplify this equation. After some rearrangement, I can write like this. Do you agree with me? DIL of t. Okay, DIL of t.
Excuse me, doctor.
Yes, yes.
Doctor, why did you
Yes.
say the current is IL?
It is given. This is the current IL. Yes. This is the current IL. This current is IL.
The polarity.
Yeah, polarity. Yes. Excuse me. Yes.
Yes, doctor. It will be like a differential equation.
It's a differential equation. So DIL of t plus 5 times IL of t, this is equal to 0. You can simplify this equation because there is a 5 here. You can divide the whole thing with 5 and you can simplify this. It become 25. So the whole equation become d of t by dt plus 5 times IL is equal to 0. Now you know for d by dt I will put d, then d plus 5 into IL of t is equal to 0. This was the way to solve the differential equation. You remember?
Yes.
So you know the solution d plus 5 is equal to 0. So d equal to minus 5. Sorry, minus 5.
Yes.
Sorry. That is your alpha, right? That is your alpha. Alpha is minus 5. This is the way to solve the differential equation. So the solution will be IL of t is equal to some constant k, right? Some constant k into e power minus alpha t. What is alpha? Alpha is minus 5. Okay, e power alpha t. That means alpha is minus 5. You can see, or we will say this is alpha, or just d also. So e power minus 5. This is the solution of the differential equation. This is for t greater than or equal to 0. Okay. Now, what is IL of 0? It is given IL of 0 is equal to 10 ampere because it is given in the question. I told you IL of 0 is 10 ampere. Is it okay?
Yes, doctor.
Yes.
So IL of 0 is 10 ampere. So I will just substitute using this equation, my equation. IL of 0 is equal to some constant k. into e power minus 0, which is equal to 10 ampere. And this factor is 1. So my K constant will be equal to 10, right? So IL of t become 10 into e power minus 5t. This is the equation for the current. Now you know this is nothing but 10 into e power minus t over 1 by 5. Agree with me? This thing, this is the general form.
Yes.
This is the general form. Yes, this is the general form 10 into e power minus t over tau. So what is tau here?
0.2.
Yes, 1 over 5 or 0.2 you can say. So tau is, that's how we will find the time constant. Now what is the voltage across the inductor? Voltage is L into dIL of t by dt. So this is nothing but L is I think L is 5 Henry, I think. Oh sorry, I didn't L is 5 Henry.
Yes.
Okay, sorry. So L is 5 Henry. 5
Minus
Henry.
200.
Yes, 10 into minus 5 into e power minus 5 t. So this become, you will get it as 5 into 10 is 2 minus 250, right? Minus 250 into e power minus 5t. So this is the voltage across the inductor. You can see again the polarity. The polarity. So the polarity is minus. So the voltage across the inductor, we have assumed the voltage like this. But what is the actual voltage? The actual voltage is minus plus. So what is this? Your inductor is acting like a source. Inductor is acting like a source.
After t equals 0, right?
Yeah, there is no t equal to 0 here, right? It is not. It is just a part of a big circuit actually. This problem is a part of a big circuit. That's why t equal to 0. Yeah, at t equal to 0 onwards, we can say at t equal to 0 onwards, your inductor is acting like a source. Is it clear?
Yes.
And your current source will give you a current according to the value of the current in the inductor. Can you tell me what will be the, so what is my current? IL of t is 10 into e power minus 5t. What will be the current source? What is the situation of the current source now? This is the current source, IL by 4. What will be the current source value now? IL of t by 4. That will be the current source. Yeah, 10 by 4. That means 2.5. So 2.5 into e power minus 5t. So your current source will be pumping a current 2.5 into e power minus 5t. And that current is depending upon the inductor current actually. You understood? That's how it is working. I hope it is clear, this part. Okay.
Clear.
Yeah. So this is the problem. Inshallah, we will continue in the next class. I think this is enough for today. Inshallah, we will continue in the next class. Okay. I think any doubt is there, Ryan? What happened to Ryan?
Maybe he disconnected.
He was asking something. Yeah, there was some problem. Maybe some problem with his connection. Okay. Inshallah, we will see in the next class. Okay. We will try to finish. I don't know how much I can finish. RC circuit is remaining. Okay. We will do some problems on RC circuit. The problems on RC circuits are in the same pattern. You understood?
Yes, yes.
There is no difference. Instead of current in
Only
inductor
voltage.
circuit, it will be voltage. Everything is same. The pattern is same. Okay. After that, we will see something different is RLC circuit. There is some difference. Okay.
Okay.
Because there are two energy storing elements, L and C. Understood?
Yes.
Then what will be
Yes,
the
sir.
order of the differential equation? What will be the order of the differential equation? If there are two energy storing elements, it will be second order. Okay.
Yes.
So you have seen the transfer function. Remember transfer function like this, 1 by s plus 1. Remember?
Yes.
What is the degree of this polynomial S1? What is the degree of this polynomial?
First order.
Is 1.
First degree.
That means, yeah, that's how many energy storing elements are there?
One.
If it is, yes, when it become RLC circuit, it become S square something, S square plus something like this.
Yeah.
S square means how many energy storing elements are there? There are 2 energy storing elements. Understood? So this is how, when you see the transfer function, this is how you can analyze what will happen, what will be the situation of this circuit, how the circuit will be looking like, what is the nature of the circuit, how you can relate the physical characteristics of the circuit by using this mathematical equation, differential equation. So this is all the meaning of differential equation. And we are talking about the first order differential equation. You know this first order differential equation? What is the solution? Solution is an exponential decay. That's what we have seen, right?
Yes.
Exponential decay. This is now what is happening to our this coronavirus, COVID-19 graph. Now you can see. Have you seen now graph in Saudi Arabia? Alhamdulillah, it is going down, right?
Yeah.
Day by day.
Yes, that's
So
right.
if you approximate this, you can see like this behavior, right?
Exponential.
Yes.
So what is the order of that differential equation which is governing the rate of change of this coronavirus? It is first order. Now it is first order decay. Now it is in first order decay. Previously it was going like this and going like this and going up, and now it is go steady, and after that it is first order decay. You understood?
Yes.
So maybe according to different factors, this first order become, if the vaccine is introduced or if some other forcing parameters are there, then it will, the time constant for that, it will be very high. You understood? Time constant is very high means very high time constant means it will decay very fast. So the time constant will depend upon, the time constant will depend upon if you are introducing the vaccine to control it, or other, if you are keeping the social distance or something, lot of parameters. Otherwise the time constant will keep on increasing. So then what will increasing, then what will happen? It will be like this. It will take long time to decay. So these kind of things, the physical nature is having lot of phenomena which are having first order and second order behavior. Okay, some are having first order, some are having second order. Okay, so you can see, you cannot say it is absolutely first order. In this case, you have to see the graph. After the graph, after seeing the graph, you have to judge whether it is first order or second order. So this is how we can use the differential equations for modeling the physical systems. I think you got some idea about differential equations, right?
Yes.
Yeah. So differential equation is giving a slope of the tangent actually. This is the differential equation. Suppose you have something like this. If you have a characteristics, okay, sorry, I will remove, okay, this is okay. If you have a characteristics like this, and if you are drawing a slope, you know the slope at this point is like this. The slope at another point is like this, tangent. This is the slope of the tangent. You understood?
Yes.
So what is the, this is x and this is y. Suppose this is t and this is y. Then dy by dt is nothing but the slope, right?
Right.
Now what is this slope? Dy of t, because y is a function of time. So dy of t. Now you see here, this slope is m1, and at this point this is another slope m2. This at this point this is another slope m3. So you can say this slope is changing. Let's say this is a function of time, you can say. So you will get an equation which is relating to the slope dy of t by dt minus m of t is equal to 0. You got the idea?
Yeah.
And somehow you can write this m of t in terms of something like a into y of t or something like that. In some cases it is not possible. In some cases it is possible. Yeah. If you have an exponential behavior, if you have an exponential behavior, suppose your y of t is e power minus t, then what is dy by dt? Again it become e power minus t into minus 1.
-1.
Do you agree with me? Yes, this is your m of t. Then I can write my differential equation dy by dt plus, I can take this to the left side. This is okay. I can take this to the left side, become plus e power minus t equal to 0. And what is my e power minus t? E power minus t is nothing but y of t, right? So I will replace this with y of t. So when you have an exponential behavior, maybe sometimes some constant will come here, sometimes in general I am saying. So in general, you can say if you have a differential equation like this will be having an exponential behavior. Understood?
Yes.
That's how it is coming. So most of the phenomenon in nature is having this kind of behavior. We can see, you can see in a lot of places, not only inductor and capacitor case, in lot of cases. That's what I told you. You carefully observe the graph of this coronavirus withdrawal, you can say, or rise. You can take the whole figure from January, from February, I think so, February or March, from there onwards, how it is rising, how it is falling. Then you can have some idea. You can find out the time constant of it. To the time constant of it, if we are going in the same situation, you can predict at what time this will end with some accuracy. You understood?
Yes.
Because at 5 times time constant, you know that at 5 times time constant the value become almost 0, right? You have just studied now.
Right.
So you first find the peak value, and after observation you find how much time it is taking for reaching some 36.8% of the maximum value. Then you will get the time constant, how much time it is taking, how many weeks, how many days. Then you multiply that days with 5. Then after that, it will reach the steady state and it will decay slowly. That's how you can predict. You understood? So that is how these software tools are doing their prediction. This is the simple method. By using differential equation, you can predict all these things. Okay, inshallah, I hope it is clear to you. Inshallah, we will see you tomorrow. Sorry for taking your time, extra time. Okay.
Inshallah. Thank you.
No problem, Doctor.
Assalamu
Alaikum
Assalam.
assalam.